As we begin 2.4, we want to go back to 2.2 because there's a couple of definitions that we're going to need to move forward. In 2.2, we learned the definition of complementary angles. That is, two angles whose sum is 90 degrees or two angles that form a right angle are complementary. And supplementary angles, that is, two angles that form a straight angle or whose sum is 180 degrees are supplementary angles. So now that we're moving into 2.4, we're going to need to prove a theorem. This first theorem, we're given angle 1 is supplementary to angle 4. Angle 5 is supplementary to angle 4. So I'm going to start with my first given. Angle 3 is supplementary to angle 4. And if two angles are supplementary, then they sum to 180 degrees. So the measure of angle 3 plus the measure of angle 4 equals 180. And if I subtract, then subtract angle 4, then I can say the measure of angle 3 is equal to 180 minus the measure of angle 4. I was also given angle 5 is supplementary to angle 4. And I'm going to subtract again the measure of angle 4. Oops, put that in the wrong spot. And if two angles are supplementary angles, then they add up to 180 degrees. Here I'm going to subtract again. Now the measure of angle 3 is equal to the measure of angle 5. So by substitution, I can say they're equal. Then if two angles have equal measure, then the angles are congruent. Now remember, when you're proving a theorem, this is not how you use the theorem in your homework. This is how you prove the theorem so that you don't have to write an 8-step proof to say, given that angles are supplementary to the same angle, given that angles are supplementary to the same angle, then they are congruent to each other. If angles are supplementary to the same angle, then they are congruent. So here's the short form, and no, you cannot make that any shorter. Angles sup to the same angle implies congruent angles. And here we have another theorem to prove. And in this fill-in proof, now we have a couple of statements missing. We're given F is sup to G, H is sup to J, G is congruent to J. We have to conclude that F is congruent to H. So I know G and J are congruent. F is sup to G is given. So then if two angles are supplementary, they sum to 180. By the subtraction property, I know that angle F is 180 minus the measure of angle G. I was also given angle H is supplementary to angle J. If two angles are supplementary, then they sum to 180. So here I want to say the measure, just following this above, measure of angle H plus the measure of angle J is equal to 180 degrees. And then by the subtraction property, I want to say angle H the measure of angle H, is equal to 180 minus the measure of angle J. And I chose to solve for H because of this, just like F is here. So now I'm given angle G is congruent to angle J, which means if we have congruent angles, then they have equal measure. That comes from 7. Sorry, this came from 4. That came from 5. So now I know I need to use lines 3 and 6. So looking at 3, F is equal to that. H is equal to that. And looking at line 8, G and J are equal. So now by substitution, I can use lines 3, 6, and 8. And then if angles have equal measure, then they are congruent angles. Once again, this is not how you do your homework. This is proving the theorem so that we can use it in our homework. So now instead of writing a 10-step proof, we'll only have 2 steps. If you were given something like this in your homework, you would write down the givens, and then you could make this conclusion in step 2 by saying, if angles are supplementary to congruent angles, then they are congruent. And here's the short form. No, you may not shorten that. And another reminder of that is you always avoid using measure in your homework. You almost never go to measure unless they give you measure in the given. So to go over this again, if angles are supplementary to congruent angles, then they are congruent. So the difference between this and the above theorem is whether it's congruent or the same angles. Let's take a look at this proof. So here they're very similar to prior. Instead of supplements, though, they're using complements. I'm going to suggest you try these on your own and use the 2 proofs that we just did to kind of follow how you would complete these. So that's for angles that are complementary to the same angle, then they are congruent to each other. And remember, you never use a theorem to prove itself. You have to use anything that's in the system prior to this theorem in the proof of it. Same thing up here. So the objective is to prove by means of 4 new theorems. And our theorems are angles that are supplementary to the same angle implies congruent angles. Angles that are supplementary to congruent angles implies congruent angles. Angles that are complementary to the same angle implies congruent angles. Angles that are complementary to congruent angles implies congruent angles. So these 2 deal with supplements, these 2 deal with complements. Each has the same angle and congruent angles, same angle and congruent angles. You may not shorten it any shorter than what's there. If you write me something like angles that are supplementary implies congruent angles, I'm going to mark that wrong. Here's an example. Angle 1 is supplementary to angle 2. Do they look congruent? No, they're not. So don't do that. You have to make sure you specify whether they're supplementary to the same angle or congruent angles, whether they're complementary to the same angle or congruent angles. Okay, the book does kind of model a proof. I don't think it's as nice as the ones that are written in our system. And then the book does challenge you to go ahead and write the proofs for the complements. Moving into the sample problems, we're given that angle 1 is supplementary to angle 2, and we see they form a straight angle. Angle 3 is supplementary to angle 4. Those also form a straight angle. Angle 1 is congruent to angle 4. I'm marking the diagram right away. I need to conclude that 2 is congruent to 3. So here I'm given angle 1 is supplementary to angle 2, 3 is sub to 4, and 1 is congruent to 4. In line 2, and remember to line up your statements and reasons both vertically and horizontally, I can say that angles that are supplementary to congruent angles. Now, the way they wrote that is a little harder to see. Congruent angles implies congruent angles. Now I'm marking my diagram, marking the angles. In the second problem, they don't tell us what to conclude. Here we see they don't tell us what to conclude. Here we see angle A is complementary to C. Angle DBC is complementary to C. Well, if angles are complementary to the same angle, and again, angles that are complementary to the same angle. Trying to line that up vertically as well as horizontally. Angles that are complementary to the same angle implies congruent angles. So that would mean angle A is congruent to angle DBC. Looking at problem 3. Your book does a couple of things that I do not want you to do. For example, this assumed from diagram. Remember, we write that as diagram implies straight angle. The same as. I don't want you to do that either. So I'm going to show you, we're going to rewrite this proof together. So we are given the diagram as shown. If we are given a diagram, then we can assume a straight angle. Now, which angle do I want to name first? HFE is an angle that I'm going to want to use to prove, and I want to watch my parallel structure. So 1 and 2 are supplementary. And GFJ, so 3 and 2 are supplementary. So I just want to bear that in mind when I choose. So angle 1 here is supplementary to angle 2. So I'm going to want to say angle EFG is a straight angle. And then angle HFJ. Actually, I'm going to move that underneath. So then in number 3, I can say angle 1 is sub to angle 2 because they make EFG. Because if two angles form a straight angle, then they are supplementary angles. And remember, the logic that we're using is the chain of reasoning, so we could, in theory, cross out the straight angles. And I want to say 3 is supplementary to 2 because that forms angle HFJ. That's the same reason. Now, if two angles are supplementary to, that's probably the wrong color, are supplementary to what? Angles that are supplementary to the same angle implies congruent angles. So here I can say angle 1 is congruent to angle 3. I believe this is the first time that you're seeing a slight change in the proof statement from our final step in the proof. But I did note that on the diagram that angle 1 was angle HFE and angle 3 was angle GFJ. As long as I note it on the diagram, then I can go ahead and number the angles. Now notice in your book they had 6 steps. We combined it and it's now 4. In problem 4 here, there's also something I don't want you to do, where they do the reasons like this. I don't want you to do the in a similar manner. So let's write this proof from scratch. Oh, and they had 6 steps. Number 1, KM, segment KM is perpendicular to segment MO. That's given. If segments are perpendicular, then they form a right angle, and that comes from line 1. So that would mean, lining this up vertically and horizontally, angle KMO is a right angle. You'll see why I left a big space there in a moment. And then, if two angles form a right angle, then they are complementary angles. So angle 1 is complementary to angle 2. Now, why did I leave such a big space in there? We were also given PO is perpendicular to MO, which would mean angle POM is a right angle, which would also mean angle 3 is complementary to angle 4. So notice my parallel structure. Everything in blue comes first. Everything in green comes second. You do want to keep a well-organized proof. So now, number 4, KMR, which is angle 1, is congruent to POR, which is angle 3. So angle 1 is congruent to angle 3, and that's given. And here we go. I'm noticing this. Angles that are complementary to what? Congruent angles. Implies those angles are congruent. So that's using lines 3 and 4 in the proof. So now I can say angle 2 is congruent to angle 4. Mark my diagram. And angle 2 is angle RMO, and angle 4 is ROM. So these are equivalent statements, the proof statement and that. And there's a 5-step proof. Looking at the problem set, you are going to want to draw out this A shape and maybe use a pen to number them. Because then you can use your pencil to say 4 is 131. Well, what's 180 minus 131? Because if they're supplementary, they form a straight angle. So that should be 49. And this is also a supplement. That should be 49. And the supplement of 49 is 131. They tell you 2 is complementary to 3. So 90 minus 49 is 41. And then the supplement of 41 is 139. So then you would have a completed diagram. That would allow you to find the measure of each of the following angles. If we did this on an assessment, I would expect you to use the diagram and label it on that. Let's take a look at an algebra problem. One of two supplementary angles is 4 times the other. So whenever you set up a problem like this, you're going to have the angle and the supplement. So the angle and then the supplement. Now to write the equation. So this is our key. And in fact, we should draw a diagram. Now we write our equation. One of two supplementary angles is, the verb is always your equal sign. My suggestion to you would be, since we have the equal sign and there's only going to be one of two supplementary angles on the left side of it or on one side of it, choose the angle with the most terms for that side. Because then when we write our other side, four times the other. 4 times the other. Now you add x to both sides. Now we get 180 equals 5. My pen's giving up on me. 5x. Divide both sides by 5. 5 goes into 18 3 times, with 3 left over. 5 goes into 36 times. Find the larger of the two angles. So x is 36, which would make the supplement 144. That's the larger of those two angles. If you do the literal translation, you will be fine. But remember, when you're setting up an angle, you set it up as x for these. The supplement is 180 minus x. And then when you get the complement, that would be 90 minus the angle, or 90 minus x. Good luck. If you found this video helpful, please like and subscribe. Smash that like button. You know you wanna. Come on, give it a thumbs up.